So that's this function is Lebesgue. That is the function e power minus x square cos of twice xt is Lebesgue integrable. Is Lebesgue integrable. This function is Lebesgue integrable. over this interval, okay, 0 to infinity, this function. Now let's see its the partial derivative. We'll see that partial derivative is dominated by some major integral function. Let's check this. Now del by del t of the function e power x square cos of 2xt. Let's see this. Let's see this mod. You have to differentiate with respect to t, so it's e power minus x square as it is. This is a constant, and then this will be here sine of 2x. It's actually minus sine of 2x, but you are here under mod, so you don't need to write here minus here. Differentiation of 2xt is 2x, okay, with respect to t. It's just this, and this function is less or equal to 1. This function is less or equal to 1, so it's less or equal to e power minus x square with 2 is always there, twice x, so we don't need mod for this because everything is non-negative. X lies in the interval 0 to infinity. E power minus x square is always non-negative, and this sine of 2xt is less or equal to 1. But this function, what's this function? This function, let's denote this function by g of x. This function is Lebesgue integrable. This is holds for all x greater or equal to 0. Since the function g is positive and improper integral of g of t exists, you can easily verify that the improper integral of g of x exists. So that's so here g of x is equal to twice x e power minus x square. Let's check its improper integral. So we see that the integral 0 to infinity g of x exists, okay. So how it exists? We have integral 0 to infinity x e power minus x square dx. So by putting x square equal to put x square equal to say y, twice x dx equal to dy. So limit is 0 to infinity again, 0 to infinity, this will be dy by 2 in fact. So x dx, it's e power minus y dy, so it's 1 by 2. What's this one? It's e power minus y divided by minus 1, 0 to infinity, but at infinity its value is 0, and at 0 its value is 1, okay. So it's equal to 1 by 2, which is the finite thing. So that means this improper integral exists. So therefore the improper integral 0 to infinity mod of x e power minus x square dx also exists, because the function is non-negative actually also exists. So therefore the function g of x is Lebesgue integrable over this interval, over 0 to infinity. So thus we have seen that this partial derivative is bounded by some Lebesgue integrable function g of x, okay. This is bounded by some integral function g of x, okay. So thus we can see f dash t thus by previous theorem of previous lecture, okay, of previous lecture. This f dash t is equal to f dash t is equal to the differentiation of the integral is equal to the integral of the differentiation. it is 0 to infinity del by del t of the function. What's function is here? E power minus x square cos of 2xt dx. Because our f of t is here. What's f of t? F of t is this function 0 to infinity e power minus x square cos of 2xt. Okay, so the derivative of this function is equal to the integral of the differentiation. That's this. It's equal to 0 to infinity. 0 to infinity. This will be minus 2 times. This is minus 2 times. You can easily verify it. It's x e power minus x square. Then sin of 2xt. This can be easily verified. You have to just differentiate partially this function with respect to x. That's very simple. Dx. Okay, this is it. Now you integrate this by parts. So keep this function for integration, because integration of this function is available. Actually, integration of this function is available. You can put x square equal to y, then 2x x dx will be equal to t. So integration of this function is available. X e power x square, its integral is available. So you can integrate this function by parts. You can integrate this function by parts, and you can write this as in minus times integral 0 to infinity twice x into e power minus x square, then sine of 2xt dx. Okay, keep this function for integration, this for differentiation. What's the integration of this function? It's just e power minus y divided by minus 1. Okay, because you can put x square equal to y, then 2x x dx will be equal to ty, so it will be e power minus y dy, which is equal to e power minus y by minus 1, that's equal to e power minus x square by minus 1. So it's equal to minus times this integration of this function, that's equal to e power minus x square divided by minus 1, okay, into a differentiating function as it's, that is sine of 2xt as it's. Now after this we have to write minus, then integral of integrating function integrate, you get this minus x square by minus 1 into differentiating function different, that's equal to cos of 2xt divided by not product, you are differentiating this function, which is equal to you are doing it integration with respect to x here. So you have to differentiate this function with respect to x. So sine of cos of 2xt with respect to x means you write here 2t. Write here 2t. Okay, this is 0 to infinity, and here the limits are 0 to infinity. Now this minus and minus will go, it's e power minus x square sine of 2xt is 0 to infinity, but at infinity e power minus infinity is 0, and at 0 sine is 0. So both when you apply the upper limit its value is 0, when you apply the lower limit its value is 0, therefore it's just a 0 number. So this minus is actually throughout here, minus times this. Now this second, it's minus minus plus, then again minus, it will be minus, it's just minus. So it's a minus times integral. It's minus times integral. What's it? Minus is integral. This one is 0. Okay, this is your 0. It's e power minus x square. It's twice t e power minus x square cos of 2xt dt. It's minus times minus integral 2t e power minus x square. Next page, integral 2t e power minus x square, then what's the it's cos 2xt, okay, cos of 2xt dx, 0 to infinity. This is equal to minus 2t times integral 0 to infinity e power minus x square cos of 2xt dx, but this is actually f of t, it's equal to minus twice t f of t. So this is very important. So f dash t is equal to f dash t is this, f dash t is this. Okay, so this is equal to f dash t, or you can write this f dash t as because now it's a differential equation f dash t, so you can write this f dash t is equal to d f of t over dt is equal to twice t minus twice t f of t. Then you can transfer this dt on this side and f of t on that side, so you will see this dft divided by ft is equal to minus twice t dt, which is d ft divided by f of t is equal to minus twice t dt. Is it clear? Minus twice t dt. Okay, is it clear? This is now you integrate this, so this means integral of dft divided by ft, which is equal to integral minus twice t dt. But here differential ft is dft, it's available in the numerator, so it's actually log of the denominator, log of f of t minus twice t square equal to minus twice t square with 2 and 2 will go, it's minus just minus t square plus constant integration, plus constant integration. So you can write this as, you can write this f of t as e power minus t square plus some c. This is equal to e power minus t square into e power c, it's again constant, let me write again as c. So f of t is e power minus t square into c, so this means your f of t is equal to e power minus t square into constant integration. But what's f of 0? It's equal to 0 to infinity e power minus x square dx, which is equal to root pi divided by 2. Okay, so f of 0 is this, so thus first gives by putting t equal to 0, this f of 0 is equal to c, which implies this c is equal to root of pi by 2. So therefore what's f of t? Therefore f of t is equal to e power minus t square into c, c is root pi by 2. So thus f of t is equal to this, that. So but f of t is the value of the integral actually, so the integral is equal to e power minus t square root of pi by 2, so which implies integral 0 to infinity e power minus x square cos of 2xt dx is equal to what? It's equal to e power minus t square root of pi divided by 2. This is the value of the integral. Okay, so that proves this theorem. And our next integral is next theorem is the following. The next theorem, it's if t is greater or equal to 0, if t is greater or equal to 0, then 0 to infinity sin x divided by x e power minus xt dx is equal to pi by 2 minus arc tan t, arc of tan t. So this we have to check what's arc tan t means. Tan inverse arc tan t. Arc tan t means tan inverse of t. We will evaluate this integral in our next lecture. Okay, in our next lecture we try to evaluate this integral. Then we have some exercises on this integration theory, improper integration. So the first exercise is that I want to mention here. This term we'll see in the next lecture. Okay, the first home assignment for you, it's evaluate the integrals, or you show that integral 0 to infinity x square x power 2n e power minus x square dx is equal to 2n factorial divided by 2 power 2n and n factorial root of pi by 2. So for n equal to 0, this 2n factorial divided by 2 power 2n, it is equal to 1, and for n equal to 0, this is equal to 0 to infinity. It's the Euler. It's again the generalization of the Euler integral actually. So this is true for holds for all n equal to 0, 1, 2, so on. Okay. This is the exercise, and one more assignment for you is the following: 0 to infinity e power minus t x square dx is equal to 1 by 2 root of pi by t. This one. So for t equal to 1, you can see, but root of pi by t, for t equal to 1, it's pi by root pi by 2. For t equal to 1, this is again the Euler integral. Very interesting, huh? This one so these two are sufficient. You will do these two exercises, and one more that's very important. One more home assignment for you, which is for each t positive. Here I have this t is positive here. Okay, t is not equal to 0 in this. So for each t positive, let's define f of t is equal to integral 0 to infinity e power minus xt divided by 1 plus x square dx. Let's define this function. Show that integral exists. First part of this. Show that the integral exists. Integral exists as an improper Riemann integral. As an improper Riemann integral. So obviously, if improper integral exists, this will be Lebesgue integral because it's a non-negative function, and as a Lebesgue integral. And obviously, you just check for improper integral. Lebesgue integral obviously will exist because it's a non-negative function, and as a Lebesgue integral also it exists, and as a Lebesgue integral. आपको सिर्फ improper integral आप check कीजिए बस as Lebesgue integral. The next part of this, show that f has a second order. Show that f satisfies the following differential equation. Show that, जैसे आपने भी उस थ्योरम में किया है, f of t के डिफरेंशियल इक्वेशन आ गई ना, वहाँ पर जहाँ पर भी आपको चेक करना है कि this f of t has also certain differential equation and it has the second order. This one, that one has the first order now, but this one has second order differential equation. Show that f of t satisfies the differential equation. What's that? F double dash t plus f of t is equal to 1 over t. तो इतना अगर आपने किया ना कि ये इस डिफरेंशियल इक्वेशन को सेटिस्फाई कर रहा है, तो वहाँ से आप इजीली कैलकुलेट कर सकते हो कि इसका इंटरवल क्या आ जाएगा. दिस होल्ड्स फॉर ऑल t positive, because you can take this t times f double dash t plus f of t. So for this you have to solve this differential equation. Okay, you have to solve this differential equation. Thank you. In the next lecture we'll evaluate, we'll try to solve that, we'll try to prove this theorem. Okay, this one.